Please pause the video and take a moment to read this important safety message.
Hey, welcome everyone. Mark here at Blue Glow Electronics. Today we're going to go on an audio adventure. I have no idea where this journey is going to take us. It may take me a while to make this video because I don't know what's ahead of me on this journey. But let's start the journey ourselves. So 2 weeks back, I get a text from a friend of mine that says, "Hey Mark, have you seen these up on eBay?" And I said, "Nope, let me go take a look." And I look, and this is the ad I found. It says Cary 805 prototype 100-watt monoblock tube amplifiers. And at the time it said buy it now of $1,300. And I'm thinking to myself, why has someone not bought these? This is a set of Cary 805s. For those that are not familiar with these, huge amplifiers, and a set of Cary 805s typically sells anywhere between, let's say, $3,500 and maybe $5,500, sometimes a little more, depending upon the deal you find. But I'm thinking, why are these still sitting here at $1,300? So I start looking a little closer here. The first thing I see, these things are local pickup only. So the guy's not willing to ship these. And then the second thing I noticed, he's in Lincoln, Maine. And I pull up Google Maps and I look at Lincoln, Maine, and I realize, holy cow, out in the middle of nowhere, Maine, not on the beaten path. You know, if these things were in a major metropolitan city, I imagine they would have disappeared within an hour and someone would have went and picked them up. But still, even at that, I'm thinking $1,300, somebody could go on uShip, find somebody to ship these for a few $100s and get a pair of amplifiers at an amazing deal. So I scroll on down and I get to looking. It says here, Cary 805 prototype monoblock tube amplifiers. One of the amplifiers has a fault and needs repair. So then I realize, okay, there's more to this story than just these are in the middle of nowhere and the guys can't ship them. It's also one of these amplifiers is not working. So I'm thinking to myself, hey, I'm an amp tech. I could probably fix one of these if it's fixable. So let's roll the dice. So that's what we did, okay? I reached out to the owner, said, hey, I'm interested in these. He said, be glad to facilitate, somebody coming and picking them up, but they're just too big and too heavy to ship. And so that's what I did. I went on uShip, found somebody to go pick these things up. A couple $100 later. Oh yeah, by the way, I offered the guy $1,200. I said, look, I'm willing to go this route. Would you drop him down to $1,200? He did. He changed his auction. I did the buy it now. And so these actually showed up at my house yesterday. Let's see, 4/5, Monday, 2021. And so, that's about a week after I bought them. It took a couple days to find somebody on uShip to get them here. But at any rate, let's go on the journey together of one, figuring out what's wrong with this one that's got a fault. And then two, what kind of restoration do we want to go through on these units? So let's do it together. Okay, before we hit the bench over here, I thought I'd just show you a couple of the pictures that were in the eBay auction. If you'll notice here, it's 3 tubes in these. It's a 6SN7 driving a 300B, driving a 211 here. Now these 805 amplifiers could either be ran with the 805 tube on the front end or the 211 here, and this set came with 211s. Just 2 300B tubes and 2 211A tubes are worth maybe half of what I paid for these amplifiers. So anyway, you can see the chassis on these. They've got some pitting and some stains. Look, they've been in storage. These are it's copper, solid copper piece here on the top. Some beautiful wood chassis. They don't look so beautiful here in these pictures, but wait till you see when we get done with the restoration on these. You can see some massive output transformers. Nothing, capacitors, the transformers, everything here identical to what Cary used. So these components had to be obtained from Cary. I thought I'd reach out to Dennis Had and find out a little more of the backstory here. But if you'll notice, all hand-to-hand wiring underneath here. But this is where it gets interesting. In this paper here, it says this is a prototype. Then in parentheses, it says constructed in an informal collaboration with Cary and resulting in an additional capacitor being put into the Cary production models. So I thought that was pretty interesting here. Then it just goes on to talk a little bit about some stereophile reviews. And then at some point in time here, it said these were in excellent shape, work great, da, da, da. So I assume this is maybe from the buyer before the current owner that I got them from, because the owner I got them from said that he never had both of them functional. He said one of them always had the fault. He never could get it resolved. So maybe I'm rolling the dice a whole lot here to think I'm able to solve something that maybe somebody else wasn't able to, but we will see here. And then it has a schematic here that's not so familiar to any of the other Cary schematics. It is in the terms of what it is, but it's drawn slightly differently. So maybe this is, from the prototype or whatnot, and then it came with a Cary catalog. So let's hit the bench and see what we can find out about these things. All right, here they are in all their glory on the bench. I've got them flipped upside down so we can see underneath of them. A couple things here. If we take a look, 25 by 11 inches, so pretty significant in size here. Might not fit on top of everybody's audio bench. Another interesting thing about these, I noticed, these are the great big 4-pin 211 or 805 tube sockets. But if you'll notice here, the capacitors are on this side. So these units are mirror imaged of each other when they were built, which I think is a really cool feature of these. The first thing I did was I just got out a chopstick and I just started going through the units one after another, just looking for, pushing on wires and whatnot, looking for broken solder joints, wires that are not connected properly, maybe something, touching the chassis that shouldn't be. Just give them a good cursory overview with a poker in some way and see if you can find anything wrong. So I went through and did that. I did find one little thing I'll show you here, but I don't think it's the real problem. But I found a wire right here, the green wire coming out of, the ground wire in the power cord is tied off to this ground terminal right here, but it's not soldered at all. It's just twisted around it. But I noticed on the other one it's soldered. I think somebody just missed that, but I seriously don't think that's causing this unit to blow a fuse. As a matter of fact, it's the other unit that's actually blowing the fuse. Okay, and since these units use a solid state power supply, the next thing I did is I just went through and checked all the diodes. And you can see over there, I'm getting like a 0.5 volt drop across all of these, and I'll check them both directions, to make sure that that we don't have either a short or an open on these units. So I went through and I checked all the all the diodes here on both units on this bridge rectifier. There's actually 12 diodes in that little bridge right there. Same on the other unit. All these seemed okay. Couldn't find anything there. Up next, went through and there's a little bridge rectifier circuit right here. Did the same thing here. Checked all the diodes inside the bridge rectifier here to make sure that they were good. And similarly, this little bridge rectifier right here and here. Did that on both of them. Didn't find anything bad with the bridge rectifiers thus far. So, at that point then, I'm looking at all the capacitors real good and checking the ends of them, making sure nothing's leaky, not finding any leaky caps. So, I haven't powered this unit up yet, so I thought maybe that might be the next step. I'm not finding anything physically jumping out at me. It's solid state power supply in these, didn't see anything with the diodes. None of the caps seem real leaky, so what do you do next? You try to power it up and see what you get out of it, and just see what's happening. I'm not even sure this is the one that blowing the fuse. I think it is. The guy said basically the one that showed up with the fuse blown in it would be the one with the blowing the fuses. However, the other one showed up with no fuse in it, so I don't know. I'm not 100% sure there. Okay, we've got the schematic here, and coming out of the main power transformer here, what I'm wanting to monitor is on the other side here, feeding to this stack of bridge rectifiers. I'm just wanting to see the high voltage and watch it climb up as I turn up the variac and see what happens here, if it blows a fuse or not. So I've got the little benchtop variac I've got here, I've used forever. It's really small and compact. So I got that turned on, and as you'll see here, what I'm measuring right now is on this bridge rectifier. I'm just going across the two red wires that are feeding it here, and I'm feeding into this, and it looks like I've got about 4 volts AC right now. And as I start cranking it up, I've got 16 volts,
26 volts, 29 volts, 40 volts, 50 volts. Good news is my power transformer is working. Whoa! Did you guys see that? We got some sparking going on in here. And so I'm going to do a little trick here I'll show you.
So what I did was I did this same setup again with the lights out and a camera mounted on top, and I turned it on slowly. Then I'm able to take and slow this picture down and see exactly where it's happening on the board, and then take that over and compare it to the amplifier and know where I've got my spark happening. Maybe you can see what I'm seeing now down underneath this board where this green wire is out here. It's just been burning and arcing there for a while, and you can see the insulation on this wire is just completely gone at this point. So let's get this replaced. As you can see here, I put a new terminal lug on this end, and in the middle of soldering this unit up. And as you can see, we got new wire around here. Unfortunately, I didn't have any 18 or 20 gauge, but I did have some 20 gauge gray and green stripe. That'll work, and this is all 1000 volt rated wire I'm using. So we've got the wire soldered in at this point, and we're starting to bring the variac back up, as you can see here. Whoop, I can see it sparking under there yet again. So maybe it wasn't from that green wire, and you know, that could make sense, because if you look at this green wire, it goes over and ties to ground. So I had my suspicions all along that that might not solve it, because this chassis is ground. Something is arcing all the way from this board down to the chassis here. We're going to have to figure this out. All right, if you can see on the bottom of this board right here, what's really happening is it's arcing from here over to the little spacer, and then it's riding along the outer edge of the spacer, and you can actually see the black lines running down it and getting to the chassis. So it's finding it's the fastest path to ground, and this is the B plus. If you'll notice, it feeds through this capacitor, through this one, through this one. It's 3 capacitors here in series, stacked up, and that's what's happening here. It's arcing from there over, which is actually to this aluminum thing, then down and hitting the chassis. So let's see if we can replace this standoff with something else. All right, so this is the beauty of Hamfest. You know, you find little bags like this. These are all ceramic standoffs, stuff like that, and you pick them up. And I was hoping to use these little ceramic standoffs, but unfortunately they're maybe not quite a 1/4 inch too tall, and the screws I have are really fine here, and they're tapped into this board. And I didn't have any longer screws, but I did find a bag of nylon standoffs that I have here, and I'm just going to end up cutting 2 pieces of it and making it the right length here that I need for this. And I've got my little Dremel or Fordham unit here, and I'll probably do this off camera, but you guys get the idea. We'll pick a spot here and cut these off. Okay, we got the nylon standoffs in there now, and we have got the unit back up on the variac, and we're going to start bringing it up. 30 volts, 50 volts. Guys, this is why a variac is so important. You know, we saw what's happening down here at 60 volts, not at, hundreds and hundreds of volts. Saved our power transformer. Didn't even blow a fuse because of the low voltage we were operating at, but yet we were able to find the problem. 160 volts. Hey, we've made it further now than we've ever made it before. I'm just slowly bringing this unit up. And by the way, that's with 39 volts input of AC to this unit. We're up at 48 volts AC input, 307 volts out here. 58 volts in, 66 volts in. You notice 465 volts. 86 volts in, 566, 98 volts in, 628. All right, we're up to 114 volts, 730, 120 volts on the input right there. We're getting 766 volts out across that. This, my friends, is why high voltage amps like this. This is why working on a 211 or an 805 or maybe an 833, any of these super high voltage tubes, this voltage will find its
way to ground very fast through shorts, through arcing. And once the arcing starts and it kind of blazed a carbon trail there, it will keep following that in the future until you solve the issue. But as you can see, we have resolved the issue at this point with this amplifier. 120 volts in, 768 volts B plus coming out of this unit. I'm not saying there's nothing else wrong with this amp. We'll continue to test, but with no tubes in it right now, just bringing it up as it is, we're getting the 765 volts or so out B plus here. Okay, at this point we've got the amp flipped over between where we last left off and now. All I did was check the filament voltages on each of the tube sockets to make sure they were in line before I plugged the tubes in. At this point I'm just going to reach over here and hit the power switch on this one. And as we can see here, getting a nice bright glow here out of this 211 on it. It's a little harder to see the filaments on these other two here. It's powering up for sure. Sounding good. All right, check out the other amp and then we'll do some bench testing on these units. I'm super happy with these. Unfortunately, these days I can't play really cool music when I'm demoing stuff for you guys anymore. YouTube has gotten where they censor everything, and if you use any music that anyone would know, then they flag it and you either have to delete it out of your video or you can't monetize the video type thing. So it's kind of a pain, but and so now I'm having to use royalty-free music. Woohoo! All right, let's look at the other amp and then we'll do some bench testing. Okay, we've got amp number 2 on the bench now, and let me flip on the power to it. I've got the variac turned way down. So this is volts AC I'm measuring off of the bridge rectifier. In other words, the B plus lines coming out of the power supply over here on this side. And then I'm clipped on to the real B plus, the after rectification here on the 211 tube. And as I start turning this one up, you can see we're getting like 55 volts AC, 73 volts DC. Keep in mind your final rectified DC here will be higher than your AC coming into your power supply. Right now I'm up at around 20 volts AC feeding in, 23 volts AC, 199 volts already with 23 volts going in, 148 volts AC here. That gets us up to 35 volts on the input. As we're climbing, I'm just going to keep climbing it slowly here. Keep in mind, no tubes in this, since it's a solid state power supply, just making sure the power supply is working at this point. 580 volts, I'm up to 66 volts. There I'm up to 88 volts, 764 over here. I keep going, that's 100 volts, 108 volts. Now I'm up to 943. Keep in mind, this is unloaded. And 688 volts over here. And if I take this all the way up to 120 volts, we're getting 1055 volts over here and 766 back here. It's a lot of voltage. Any rate, we won't be running this. I'll probably run this amp down around 110. I'll use a bucking transformer setup for it. But the good news is we're getting the B plus out of this. Let's check a few more voltages. Now I'm over here on the plate of the 300B, 471 volts. So we're getting the voltages we should be throughout this amp at this point. I'm going to put the tubes in this and the other one and bring them both up. Maybe see how they sound, and then maybe we put them on the bench and do a little bit of performance testing on both of them. Okay, I'm on the second amp here and powered it up, and it's actually playing well. I'm gonna show you guys some specs on it here next. But one thing I've noticed is if I bring it up on a variac, I have no problems. If all I do is hit the power switch, it pops the 3 amp slow blow fuse. So I'm gonna throw a thermistor in line and gives a little bit of a soft start there, see if that solves that problem. If not, I'm going to dig in deeper into seeing what may be actually causing that.
Okay, the thermistor I'm using here is an SG160, and the reason I'm using those, I happened to find a bag of them, about 20 of them at a Hamfest once, so I just happen to have some on hand. But what this is, if you look here, it's an NTC, or otherwise known as negative thermal coefficient thermistor, which means that when the thermistor is cold, in other words, no current flowing through it, you just turn the amp or device on. When it's cold, this thing will have some resistance to it. Right here, it'll tell you around 2.5 ohms at 25 degrees Celsius here, so at cold. So what happens then is as current flows through this thermistor and as it warms up a little bit over a few seconds, what happens is this resistance then goes down here to 0.03 ohms. So at that point in time, what it's really doing is it's kind of getting out of the way. And what this is, and it says it right here, it plays the role of an inrush current limiter. So when you first turn it on, there's some resistance here. As this thing warms up a little bit, the resistance goes away and the current flows the way it needs to. This unit's rated up to 15 amps, so we're good to go.
Okay, at this point, I'm able to take amp number 2 and power it on, and the thermistor did the trick. It keeps it from, keep in mind, this thing, look at these, there's 4 really big capacitors here on this unit. When you got really large capacitors, when you first turn the switch on, you get this inrush of current that it takes to charge these capacitors, so just high inrush current. And then once they start charging a little bit, you kind of go back to your normal quiescent level. I thought this was interesting. This tube looks like it's leaning. The tube glass is actually not. It's the stand inside of this 211 isn't exactly straight. So quality control there at GE back in the day. Doesn't affect performance, but I've got some other 211s. I may swap this one out at some point. Let's see what we get here. Sounded good. Let's take a look at some bench specs on this. Okay, 1 kilohertz tone feeding in here from the 8903. Let's see. Let's feed it at near line level. We're getting 0.46% distortion out of this unit right now, so pretty low there. Let's drive it all the way at line level. And we're at 0.5% distortion, so let's run some sweeps and whatnot on it.
Okay, I'm using the audio analyzer suite for the analog discovery by the Stuff Made. Can't say enough thanks to them for making this. Anyway, I'm going to sweep from 20 hertz to 20 kilohertz. I'm going to measure THD plus noise. I'm going to do 20 sweeps, and I'm running this on channel 2 because I've only got 1 amp running at this point. And so we're kind of comparing on one axis here the audio spectrum, so down here at 20 hertz all the way up to 20 kilohertz. And on this axis, we're measuring percent THD plus noise. So if we'll notice here, this right here where my cursor is pointing is the 1% line of distortion. So this unit, a little bit of distortion here at 0. Let's see, I'm at 28 hertz right here. So as soon as it gets up to around 40 hertz, we drop below 1% distortion, and we stay below that all the way through the 20 kilohertz. Matter of fact, through a lot of the audio range here, if you'll notice, we're down at 0.25% distortion. So keep in mind, this distortion is varying a little bit with frequency across the range. But this is fairly, if you kind of looked at, say, 50 hertz or so, right here I'm at 41 hertz. From there across, we're pretty darn flat across the frequency spectrum. Okay, this time we're just going to run a frequency response and just see how this unit responds from 10 hertz up to 50 kilohertz. Wow, that's pretty good. So look at this. All the way right here from somewhere around, let's see, that's at 38 hertz. Right, so somewhere right in here, that's all the way down where I'm at right there. That's 24 hertz. So from around 30 hertz all the way through right here, we're at 20 kilohertz. Then it takes a little uptick, and we don't care because we can't hear any of this. And then it kind of dies off here around 31 kilohertz. Pretty pretty good for what this thing is. I think this is pretty darn amazing. Nice little frequency sweep here.
Okay, my original intent on these amps was to finish the restoration completely on them and wrap that up in this video so you'd see the beauty of them as well. I've changed my mind on that, and here's why. I've started down the journey of polishing the copper, and what I've got here, it had a clear coat on it of some type, protective coating, but you know, they've still been etched, and it's just bad. So I'm having to remove that clear coat off the top. I'm having to use 4/0 steel wool. Then I'm going to have to come along and polish out all the swirl marks from this 4/0 steel wool. I'm going to have to neutralize it and put another clear coat back on top of it, which means I'm going to have to pull some of these components out to do that. That's going to be really time consuming. But even more so than that, these units have some amazing wood to them. These are mahogany cabinets, and what I want to do is take the chassis out of the wooden frames, and I want to take these wooden frames over to a cabinet worker, have them sand them down, restain them, spray a coat of poly on them, and do it right. And my fear is that's probably going to take a month or two to get all that done. So I'm going to go ahead and wrap the video without the restoration. I'll just show it in a Soapbox Sunday or something later. You guys can see the beauty of them when I get them done. Or maybe this will be one of the first things I do in the new listening room when we get them done. So stay tuned. Hey, a couple more things though.
So if you just Google Cary, 805, lots of articles out here. These things were all the rage for many years. And these are some good articles out here, but it goes on. This is a good one. It goes on to talk about, a lot about Dennis and what he was trying to do here. Let's see here. It talks about, started out in 1993 at $7,495 a pair, and the anniversary edition was $11,000 a pair. That's a lot of money back in 1993. I'll tell you, you could have bought a car for the same price. Matter of fact, in 1987, I bought an RX-7 brand new for less than this. So it's a lot of money. But it goes on to talk about some of the iterations, and this amplifier was designed to put out 50 watts or so, okay? And they talk about how they achieve that. It talks about here, these things were originally an A1 design, but then they used the interstage coupling capacitor. So beyond 25 watts, the drive signal from the interstage transformer kicked in, sliding the amp into A2, causing the grid to go positive and draw current, which is okay as long as you design around it. And as a result, they could, push these things on up there towards 50 watts or more. It actually goes on, Dennis talks on in here somewhere about how he's gotten as much as 70 watts. Right here with the 211, this amp is good for 70 watts. Right now, I'm getting about 38.5 watts out of these before the distortion gets up there. And I think the reason is, one, the 300Bs in them are at about 60% their GM right now. So I've ordered a new pair of 300Bs for these, and I've not tested the 211s. I need to kind of do that in circuit. But I'm gonna drop in a new set of 211s as well, was my point. So when we bring these back in a Soapbox Sunday, or maybe show you as part of the listening room or something, I'll have all the new tubes in it, and hopefully we'll be getting closer to the 50 watts. All right, so as I mentioned, I shot Dennis Had, the founder and owner of Cary for many years. I shot him a note about these amplifiers because remember it said it was a prototype. Here's the response I got back from Dennis. Mark, great to hear from you. In regards to this CAD-805, I have no idea where this came from. Looks like someone simply dropped down a version of an 805 and stuffed it into, what the heck, not during my reign at the helm. So I have no idea at this point. Me and a buddy of mine were talking last night, thought maybe somebody had a set of Cary 805s and dropped one of them, bent the nice chassis up. So they built these these wooden and copper chassis to move everything over into. That's one option. Maybe two. Maybe somebody that was working at the Cary factory had some parts, on the side and built their own amplifiers. I don't know. We were struggling to come up with the mystery here. So if anybody has any ideas, feel free to kind of post them and tell me what you think really has happened here. But it's a mystery for sure. But I can tell you the components in these units couldn't have came from anywhere but Cary. I mean, the feet on the bottom are stamped Cary Audio, right? The interstage transformer, that was a Cary specifically made device, right? These power transformers, the output transformers, these were not off the shelf items. These were specifically made for these. Matter of fact, the part numbers on these match up with the modern schematics for 805 amplifiers on the transformers and whatnot. So I know all this stuff came from Cary. I don't know. It's a mystery. All I know is I'm happy to have them. And they sound great. And what the heck, as Dennis said here. Thanks for watching, everybody. Hope you enjoyed this one. We'll keep bringing you these things.